On an '05 Suzuki Verona, we are testing the TP sensor. The ECM supplies a 5 volt to the TP sensor. At wide open throttle, it should read at 5 volts, and at close, it should read 0.5 volts. I want to point out that the TP sensor and the MTIA are in the same wiring diagram. Here we can see the wiring diagram. Red wire is the 12-volt ref, dark blue white is the motor position, gray is the 5 volt, dark blue is the TPS signal, dark green is ground, orange black is motor negative, dark blue is motor positive. Here are the DTCs for the TPS sensor, which is P0121, P0122, and P0123. The '05 Verona was a cable throttle, and now we are looking at an electronic throttle with the '06 Verona. The electronic throttle has two sensors. The first sensor ranges from 0.7 to 4.3 volts, from 0 to wide open throttle, and the second sensor ranges from 4.3 to 0.7 volts, from 0 to wide open throttle. Here's a wiring diagram of the electronic throttle. We have a 5 volt ref, TPS signal, TPS ground, TPS2 signal, and the throttle control motor. All DTC for throttle position sensor will illuminate the MIL. For electronic throttle, there are two sensors, therefore there are two different codes for each sensor. We also have TAC and APP. Here are the graphs for the sweep test. This one's volts and this one's ohms. For the volts at closed throttle, we had 5 volts, and as we progressed to wide open throttle, we had 0.5 volts. For ohms, we had 1 kilo ohms when it was closed throttle, and as we progressed to wide open throttle, it went up to 1.5 kilo ohms and above.
Okay, we're going to be doing a sweep test with ohms on the throttle position sensor. And there's full open. And then we're going to let it roll back down to closed.
Here's a picoscope of the electronic throttle, and as you can see, as we go towards wide open throttle, the voltage goes down. At the end of the lab, a picoscope gives us a more accurate reading than a volt or ohm sweep test.
Okay, welcome to the ECT part of this video. We actually ended up finding a few issues with our ECT system and also a programmer issue that we ended up resolving, but I'm going to talk about that for a little bit. This is a time-lapse of our ECTs. This is just showing the readings that we got from the first reader that we used, which was incorrect, but this is just its readings over time. And then we get into of the ECT, and there's a time lapse of that and how they change over the course of time, how the voltage decreases on the negative coefficient thermistor. But our issues that we found throughout the system, the first code reader that we had, if you remember from that, was reading in Celsius, and it was also reading -14 on the coolant and -12 on the IAT, which is obviously incorrect. But they increased over time, and it didn't quite make sense to us. So we went through and began testing all of our pins, and I have footage of that a little bit later on. so we unplugged the ECT and the IAT, and our scanner data is reading 68 rather than -40, which means that 68 is what the card defaults to whenever those sensors are out of the picture. Okay, so we unplugged the ECT, and this is the voltage reading that we're getting. As you can see, it's unplugged down there. And now we have just jumped the ECT, and we're getting 0 volts. You can see. Okay, I'm now going to unplug the ECT with the temperature pit up. We're gonna see what that does. As you can see, it jumps back to the default of 68, and I can. Okay, so with the different scanner, we have updated coolant temps. This is with the sensors plugged back in, and we're reading in between 66.2 to 68 on coolant temp, and 68 to 69.8 on intake air temp. Okay, here we are testing different resistances in the coolant temp sensor circuit because of the faulty readings from the first code reader. And throughout this, you'll see we test in between the ECT connector and one of the harness connectors, and then the harness connector and the ECM connector. But unfortunately, I guess I didn't get a clip of it, but we tested the ground from the coolant temp sensor all the way to the PCM, and there was 4.1 ohms of resistance. But due to the snap-on scanner functioning properly, we figured that 4 ohms in a circuit that can have anywhere from 100 to 10,000 ohms didn't really matter. Okay, here is the resistance of the ECT and then here is the resistance of our intake air temperature sensor at ambient air temp. Okay, and then here is the wiring diagram. As you can see, the ECT sensor communicates with the ECM. It's your typical negative coefficient thermistor with 2 wires, and it is a single range ECT. It's not dual range.